Hello, everyone. Hope you had a great gRPC conf this morning and had a great coffee break now. So we're going to talk about the new hotness in the industry, which is building LLMs and connecting them to various resources or APIs. And that is done these days by something called MCP. So we're going to go over that and see how we can leverage gRPC for that. As for me, I work at Signeen, an authentication company. Before that, I was on the gRPC team and have deployed gRPC at various companies at scale. So we're going to see how we can leverage the existing learnings that we have from gRPC and apply them to AI workloads. So what are we going to talk about today? First, I'm going to give you a brief overview of Model Context Protocol, or MCP, and talk about how we can leverage gRPC in that, and then how we propose you should run MCP servers in production, and then we'll address questions. Note that there's no answers there necessarily, so it's just questions. So let's talk about what MCP is. So as you can see in this slide, there is this application that is essentially your chat app or like your IDE that's powered by AI. That app is connected to LLMs. Usually this happens with OpenAI API because they were kind of first and everyone else basically implemented their endpoint. And then there is this MCP server, which is what we are going to focus on today. And that protocol is MCP. So it is a protocol, but they kind of talk about it as like some sort of ecosystem or like hype it up, which is natural for AI people. And they call that app MCP host in some context. So if you hear MCP host, just think that client app that is talking to LLM and the server. It's not anything like super special. So how does this thing work? So basically, like that white square is your app, and it instantiates some client object. You might think of it as a gRPC channel. And that talks to your MCP server, which provides the resources over a bunch of transport protocols. Basically, the two that are supported today is standard I/O and HTTP with streaming. So we need that streaming for notification from the server to the client, which is the MCP host. If you think about it, that standard I/O, that dates me, but that's basically fast CGI. They call it standard I/O, but that's how it works. Like, why not just do CGI? So that pattern you're gonna see over and over again, which the mistakes that people made over the years has no effect on the design of MCP, and they basically did a hackathon project that took over. And as we know from any networking protocol, adoption is what matters and not the technical merits. So they have adoption. So we're gonna talk about them today. So payload. So what does actually get sent over this protocol? They have three primitives. I imagine this might change in the future. They basically bucket stuff in resources, prompts, and tools, right? So what is a resource? It's essentially like a calendar entry, a file, an image, whatever or a database record. You can basically assign an ID, a URL to that, a URL-like thing, basically, that identifies that resource and fetches it and feeds it to the MCP host, which is the app, and that sends it as a context to LLM, but depending on how it wants to do that. And essentially, you have a bunch of resource APIs that lists the resource that your server provides and reads it and does things with it. So this is like basically the resource API. And these are kind of fixed, so the resources are pretty simple. Then there's this prompt thing. So what is the purpose of this? Essentially, you want to provide a set of commands to your application, extend your application with a bunch of commands. Imagine, I think the way the designers thought about this is like slash commands, where you invoke an operation from an end user perspective and gives it some arguments, and then that is got to get passed to your MCP server. The MCP server translates it into a string that then gets fed into the LLM. So that's the goal of the prompt thing. And as you can see, like this is kind of like not really related to the resources necessarily. So again, like this shows this protocol is somewhat ad hoc and does the job, but is not really designed from a principle standpoint. And then there are tools. The tools are really what the APIs that the MCP invokes, the actions that you get from the LLM happen in this tools thing. And that is a lot more complicated. The tools API effectively looks like something like gRPC reflection, where you can have a bunch of methods, and the method description is fed as a part of JSON response to the MCP host. And then those operations can then be invoked by the host app. So essentially, API design is dead, and we have to rethink about API design as this new thing. So why do we care about gRPC in this context? Well, it is trusted and proven, right? So we have gRPC infrastructure at scale. We run it. We know how to run it. And a lot of companies have built around gRPC. So adding a new protocol in the mix is going to be, even if it's better or worse or whatever, adding one is not necessarily good because you have all the bells and whistles around gRPC already. And gRPC has the performance, has the robustness. It's one of the most well-tested HTTP2 stacks if you're using that transport. You have already health checks around gRPC services. You have like deadline propagation. You have circuit breaking around it. Streaming RPCs is one of the core features of gRPC. And we're going to get back to this because MCP really benefits from something like that as a core functionality of your RPC stack that it runs on. The other benefit that a lot of us have seen is that you can use gRPC in any language, basically. So you don't have to wait for an MCP SDK or have an ad hoc HTTP server in your application in a certain language to be able to use MCP. Basically, create an MCP server in your desired language. And then, like, gRPC has all the service discovery, name resolver that you have in your large-scale infrastructure. It has the load balancing policies. You can control your gRPC client with XDS. It supports versioning. This is one of the things that is missing from the MCP designer's initial spec that is going to be a problem, is that your API is not really versioned appropriately. Authentication and security. This is another thing that MCP servers usually mess up with because it's not really thought about at the beginning. Whereas if you have a gRPC server, you can leverage all the authentication flows that gRPC has. You have observability, stats, tracing, like you can collect latency across your infrastructure if your server is actually gRPC. So how we can mix up the two and essentially expose our gRPC services that are running in our infrastructure as MCP. So we have three deployment models. One is a local binary, which is essentially an STDIO server, MCP server, that talks over gRPC to a server somewhere else. And that is implemented with gRPC, essentially. And then the other deployment is gRPC to MCP gateway. This is similar to our existing gRPC gateway transcoding solutions that we can use. And then there is an Envoy plugin that is also mapping very well to what the transcoder does. So there is one thing that needs to be pointed out here. Often gRPC is thought about as a protocol, as an RPC protocol that uses protobuf. it actually is not true. gRPC is completely agnostic to the serialization format. And you can essentially pass the same JSON objects over gRPC and get almost all of the benefits that I talked about here. So do we need transcoding in that context to map the MCP request and responses? What are the trade-offs here? Well, one trade-off is if we define a transcoding spec today, the MCP spec seems to be in flux. So that transcoding might not be the best thing for the future, and the conventions are changing. So maybe in the future, it makes more sense to have a full transcoding like standard, but it might make sense to do something as a middle ground. So the prompts and the resources APIs are pretty fixed today. So we can transcode those and have a protobuf server. And the rest of them, for now, it seems like it might be a good idea for the tool input and output to remain JSON so that we get the flexibility should the MCP spec changes. But that's obviously something that you may want to think about today in your infrastructure. So isn't this just the same problem as we had with like exposing a gRPC endpoint as JSON API with like a gRPC gateway thing? Well, not quite, because first of all, this is not a REST API. This is like a JSON RPC API. It's slightly different. The other important thing is MCP is fundamentally stateful, and it relies on bidirectional streaming to some degree. So that makes it a slightly different problem. So you kind of want your gateway to keep track of the state and invoke a bidirectional RPC, streaming RPC, and connect to your backend that way potentially. Or have some lookup table to manage the state so that writing that service from a backend perspective would be easier. So those are the differences that this problem has. So we have actually implemented a prototype of something like that, and we'll probably be able to share it soon. If you are interested, definitely send us an email, and we're gonna notify you when that happens. And I think I'm almost out of time, so let's open it up for questions. Please.
I think if you take a recent public MCP clients, you won't find gRPC. You'll find standard I/O or HTTP, right?
That's correct.
So what do we need?
So the server that I described, there is a HTTP server that we have currently that speaks gRPC. So essentially acts as a translator in between the two. So you can optionally, so this is something that might happen in the future. I think MCP people are open to having other transport protocols. They already support two. And I don't feel like they're very strict on not adding them. So there might be, it might be valuable to start an effort to actually standardize gRPC as a transport protocol for MCP. And okay, awesome. Because it actually fits very well because of the bidirectional streaming. So we should definitely talk about that. I mean, are you working on it, or is Anthropic also helping you? Because I mean, if honestly, if we were good at adoption, gRPC web would have done better. But we'll see.
All right, as if I'm not loud enough. Okay, so hi, Mehrdad, long time no see. There are a couple of, so one thing to keep in mind is using a bidirectional stream in gRPC for MCP does, it does most accurately reflect what the currently defined MCP protocol can do, but it's still a very poor fit for, there are a lot of cases where you want to use existing infrastructure that was designed to operate on a per RPC basis for things like authc, for example, right? I mean, you can imagine use cases where you want to apply a different authc policy depending on which MCP tool is being called, right? And it's really difficult to do that if it's all on one BiDi stream, right? So we really, So I've been working with the MCP transport work group. There are discussions going on. Everybody is not always in agreement, but there's a lot of discussion happening. We are trying to do a few things. One, you mentioned that they already support multiple transports. You can have any color you want as long as it's black. You can have any transport you want as long as it's based on JSON RPC. That is their current stance, which is not very useful. So we are trying to get like a real transport abstraction introduced that will actually allow pluggable transports. We are also trying to get some changes into the protocol that will eliminate a lot of the statefulness by default. We want to make it a much more stateless protocol, except in the cases that need statefulness, which can explicitly start a session and do what they want to do, that way. And we think that by making these changes, we can get it to a place where we can make a first-class gRPC transport for MCP. There is a remaining open question then of whether Anthropic will accept it as a first-class thing in their SDK or whether we'll have to publish it as a side thing. But we, Google, are absolutely committed to having a gRPC transport for MCP as a first-class thing, and we are actively working on this.
Well, that's great to hear. I mean, obviously, adoption is going to be slightly painful. The other thing I would recommend to definitely work on is currently the public proxies are not that great in like terminating MTLS and passing authentication. It's not a fundamental technology problem, but it's an ecosystem thing, and that is probably something that drives people towards JSON RPC or other inferior technologies, I shall say. Anyway, let's move on to the next question, please.
Yeah, on your deployment models slide, I see you're listing off 3 different ways, and on the far right, there's an Envoy plugin way. What's not clear to me is, have you had success using that, or is that something you hypothesize could be done?
So the one that we actually concretized is the middle one, which was the HTTP server. Actually, it's the same binary that speaks HTTP and SDIO that then invokes gRPC. We haven't started on the Envoy plugin, but that's something that we are planning to look at. Do you anticipate a particular problem with that?
No, it's just something that seems intriguing. Is there some way we can follow to see how the Envoy plugin is going?
Well, it's not started. The implementation has not been started yet, but definitely send an email to us, and we're going to follow up with you once something is ready for consumption. But I don't think, I mean, if you wanted to take a look today, there is a transcoding plugin for Envoy for regular JSON endpoints. And I think that's a first step to look at.
Okay, so effectively build on top of that, extending or building something like that.
But then there is the state management problem that you might want to have a database or something that keeps track of the state too, and then invokes like stateless. There are things that you can do there as well, but we're gonna take a look at that. That is definitely the most interesting deployment model that I anticipate, and it fits with the rest of the gRPC ecosystem, because a lot of people who use gRPC end up moving their edge to Envoy because of XDS, and having the same essentially control plane for both of them. So that makes a lot of sense if that materializes. But we're going to keep you posted.
Yeah, that'd be something interesting to learn about.
Yes. I have a question. How does MCP and the service discovery go in place? I mean, for instance, when you're registering this gRPC-based services into a XDS with specific keys to discover the services, and when the LLM the prompts come, they need not match with each other, right? So how do they work together?
So I don't think it's the XDS and service discovery will operate at the gRPC client level, which is within our binary. So the incoming MCP stream has no ability to see the XDS data at all. At the edge, we basically take the XDS info and route traffic to the gRPC instance, the server instance that we want to. And this is like any gRPC client. It's not that different. The thing is, because of the statefulness, that gateway might want to keep a single bidirectional stream to that server and then keep another HTTP stream to the client.
But which takes an intelligent decision? Hey,
The gRPC,
which service,
the gateway.
which gRPC service I need to invoke?
This is going to be the edge gateway at this point. But if we actually manage to take gRPC to the essentially the endpoint, then we can have the alternative solution where there is the client MCP host that directly takes XDS information. You can actually see this in one of these popular file sharing apps that uses gRPC. The client SDK, the client app talks gRPC to the server, and also their infrastructure internally is gRPC. But for example, they have web interface, and that is like some transcoding at the edge that happens there.
Oh, so it is the MCP host or the app that does the service discovery, not the MCP server.
The MCP server here is ambiguous. There is a it depends on your deployment model. If your MCP server is a local binary, then that can directly take XDS information. If it's running on the edge, then the edge will make that decision basically. So wherever your gRPC client sits, your initial gRPC client, that will take the XDS info. Otherwise, I mean, we can't do much. I mean, you can actually use Envoy and take like JSON RPC stuff and route it. But then that is fine if you don't particularly care about gRPC and other like stats and stuff within your infrastructure. That might work. But if you do, then it is valuable to actually pass the MCP data within a gRPC stream.
Got it. Thanks.
Is this the last question?
How this effort and maybe what you talked about related to what was announced earlier today, that like every...
What I'm talking about is the thing that was announced today.
Oh, because that sounded like something that actually exists, but what you're talking about something like a potential future.
Our intent to build something.
Oh, it was only intent.
They weren't announcing something that like you can go download right now.
Ah,
We're working on it.
bummer.
I hope it doesn't take as long as gRPC Rust.
We hope to have a proof of concept SDK for Python out probably in the October-November timeframe. No time frame for Go.
So I guess I shall repeat your answer, right? For the recording. October, November of this year or next year?
For a proof of concept Python SDK that has gRPC support.
Proof of concept Python SDK that has gRPC support, October, November. We're gonna take your word on that. Any other questions? Awesome. Thank you all for being here, and thank you very much.